Hello, this is Brandon Clayton, the Algebra Guy. Thanks for tuning in again. As you see, our topic, represent domain and range of quadratic functions with inequality. So we're going to definitely talk about domain and range here. For some reason, this seems to be a big challenge for a lot of students, but we're also going to talk about key attributes that you want to be able to identify with any quadratic, parabola, however you want to call it. So let's jump into it. So as you see, we're going to cover two important techniques today. The first is determine the domain and range of quadratic functions and represent the domain and range using inequalities. So we're definitely going to cover both of those, whether you're given a graph, an equation, or an application problem. So the second one is 7a, graph quadratic functions on the coordinate plane, and use the graph to identify key attributes if possible, including x-intercept, y-intercept, zeros, maximum value, minimum values, vertex, and the equation of axis of symmetry. We're going to hit every single one of those topics. So if you don't know or you are just a little bit shaky on any of those, stay tuned throughout the whole video so that you can be more competent and confident in those areas. So let's jump into it. So let's start with this problem here. What is domain and range? So I'm going to use a golf shot to illustrate this. I know I should have used a basketball shot or a soccer ball. Not most of us play golf, but you can still get the idea. So I want to discuss domain and range just using this golf shot. So I'm going to assume you don't know anything about domain and range, and I'm going to try to discuss it with you in a very basic way. So stay with me. The domain of a function, what is domain? The domain of a function is a set of all real values of x that would give real values of y. So the way we talk about domain is simply are all the possible x values of some function. All right, so what am I talking about? So let's look at this line here. How can I represent all the x values, not the y values? As you see, the y values represent the height of the ball. How do I represent all the possible x values, all the possible seconds that represent this graph here? So if I took one point on this graph right here, this point would be 160, right? Because it's at the coordinates 160. So I could have an x value of 1, I could have an x value of 1.5, I could have one of 2, 2.5, I could have an x, all these. How can I represent all the x values of some function? That's what domain is concerned about. But I'm not concerned about just the ones that are written on here. I'm also concerned about the ones in between those main numbers that they're using as intervals, or what do you call this? The way they're sectioned off. They're jumping in 0.5s by 5/10 each time. But I want to know about all the numbers in between, right here, between that 5/10 and 1, between 1 and 1.5. So how do we represent that to say, I want all the domain, all the x values for that? That's discussion of domain. All right, so we established hopefully pretty clearly that x represents all the, domain represents all the x values, all the possible x values. So from 0 right here, all the x values from 0.5, 1, 1.5, 1.75, every single number in between are the x values. Notice I'm ignoring the y values here because I don't want to include those for domain, just the x values here for this graph. So it goes from 0 all the way to 4. I want to talk to you about how to represent that as an inequality, but before I do, I want to make sure I cover this word as well, because this comes up sometimes too. Know that the domain or the x values represent the independent value as opposed to the y, which is dependent. What do I mean by independent? Well, independent means to be self-sufficient or by yourself. In this case, time, which one would have to happen first is a question students often ask to understand which is independent. As time passes by, the ball travels higher or lower. So the height of the ball depends on how much time passes by. So that it makes the x values independent because the height of the ball is dependent upon how much time passes by. Where is the ball going to be at 80. When is the ball going to be at 80 feet? Well, it depends on what time it is. At 2 seconds, it's going to be at 80 feet. So time has to go first. Matter of fact, anytime you have time in any other unit, most of the time, no pun intended, you're going to have time be your independent, because nothing stops time. Time is going to determine everything. So we measure many things by time. So that's the independent value. Now, how do you represent the domain of this function with an inequality? Remember, our inequalities are the greater than, less than, greater than, less than, equal to, and so forth. So how do you represent this as an inequality? So there's a few ways that you can think of this, but there's a common way that it's going to be written on the test. So one way you can think of it to start is, what's the lowest and highest possible numbers you can include? So the lowest number I can include is 0, and the highest number I can include is 4. But how do I write it in such a way as to say I want to include all the values in between 0 and 4? Because if I just said 0 and 4, this would be incorrect. While 0 and 4 are x values that are part of this function, it does not represent the full domain. So how do I represent 0, 1.5, 0.5, 0.75, every decimal in between? Well, here's the way you're going to see it written. So if I put an x in the middle, I can represent it with inequalities. Reading from the x, and this is important, start from the x and going to 0, I would say that I need all values of x that are greater than 0. Well, that makes sense because I have 0.5, 1, 1.5, all those values are greater than 0. Well, can the values also be equal to 0? Sure it can, because I don't see an open circle here. If there were an open circle here, that would mean it cannot equal, but since it's not, I know that it's going to also be equal. So that's how I represent it on the left side, if you will. Well, how to represent the 4? Well, I want everything that's equal to 4, but less than 4. So I could write it this way: x is less than or equal to 4. Now, again, I want to draw your attention to how I'm reading this. I'm starting with the x because your normal tendency when we read a sentence is to read left and right. We want to say 0 less than or equal to x, less than or equal to 4. But the proper way to read it, and to make more sense, is to say x is greater than or equal to 0 and x is less than or equal to 4. So all values between 0 and 4. That includes decimals, whole numbers, and everything, all the fractions in between. So this would be the proper way to represent the domain for this graph. What about range? Well, we just talked about how it's dependent on what happens with the independent variables, the time. And we can also go ahead and assume that range is going to be all y values now. So y, all the y values. So let me erase our discussion with the x so we can kind of clear our minds from that. But what about the y value? So I want to know about from 0, this is 0, all the way up to, it looks like this graph goes to 80. That's as high as it's going to get. So I'm looking now at my y values and thinking, what are all the possible y values of this function from 0 all the way up to 80? So I could say this is going to be from 0 all the way up to 80. And can it equal 0? Yep, it can equal 0, and I almost went to 4, but we're doing y, so all the way up to 80. There's no open circle there, so I can include that point as well. So this time I'm going to write a y. And let me tell you something. It's going to be simple. If you just remember that range is associated with your y values, you're going to oftentimes be able to eliminate half of the answer choices. Yes, I said half. That means 2 out of the 4 choices, because they're going to literally they're going to say what is the range, but your answer choices are going to have x values that say x is greater than 2 and so forth. Well, you know range is going to talk about your y, so go ahead and eliminate those quickly. And we might see those in our star problems here toward the end. So let me go ahead and finish our inequality. So I know that the y has to be greater than 0 because it goes up 10, 20, 30, and all the little numbers in between, the decimals and fractions in between, and it could be equal to 0, but it's going to be less than or equal to 80. So everything below 80. So it's in between 0 and 80. It can't go below 0, but it can go above 80. And this is how you're going to represent those inequalities. So if you get that, you're solid, you're good. This is going to be a gimme for the test. If you don't get it, stay tuned. I want to do some more practice problems with you. All right, so let's take this same graph and let's identify some key attributes for this. I'm not saying half the questions, but many of the questions on the test involve vocabulary. It's simply asking you, do you understand what these vocabulary words mean? For instance, do you know what x-intercepts are, y-intercepts, zeros, vertex, and how to write the equation of an axis of symmetry? So if you know these words, you're going to be like, oh, duh, that's just so easy. This is simple. But if you don't, you're going to struggle trying to guess. So let's make sure we understand. X-intercept. Well, that's simply where the line right here, also called the graph or equation or function, we call it many things. We'll say this function or this graph. When we say graph, we're not talking about the coordinate grid. We're often talking about the graph of this parabola, what the graph that it made. So when this graph crosses the x-axis, here's the x-axis here, and here's the y-axis. The x-axis is horizontal while the y-axis is vertical. So you're going to follow this and say, where does it cross? It doesn't cross here because here's the x-axis. You're going to keep going and it's going to hit there, and you're going to say it crosses there at 0.00. And it also crosses here at 40. So when I ask what's the x-intercept, that's going to be really simple for you. Oh, that's 0, 0, and 40. Well, remember that zeros are also another way to name x-intercepts. So they're going to be exactly the same. 4, 0. And don't confuse the 4 and the 0. Remember, we name our x first. So 4. So if I start at the origin and I name this point, I'm going to start with my x values first. I'm going to go 4 and then 0 because I can't go up. So I start with x, then y. Y-intercept is going to be where it crosses the y-axis. Here's my y-axis. Where does it cross the y-axis? It happens to cross exactly at the same place where it crosses the x-axis, so at 0, 0. What is vertex? Vertex is going to be the highest point or the lowest point on the graph, on the parabola. So you see the peak of that ball stop up here. Well, it doesn't stop, but that's the highest it gets. This is my vertex. What point is that vertex? We're going to call that 280 because it is 280. 280. Is that a maximum or a minimum? Even if you didn't know the specific vocabulary of that word, you can probably guess what max and min are and figure out which one this is. This is going to be the maximum because that's the most that this is going to go up, as opposed to the minimum. If it were open down like this and you had a piece right there, that'll be a minimum. So we're going to stick with maximum for this because that's what this is. Now here's the one I want you to be careful about. Let me see if I can sketch this out. So you can see this clearly. So we want an equation for the axis of symmetry. Where is the axis of symmetry on this parabola? Remember, symmetry means something divided equally into two parts. If you remember the butterfly activity that you did in elementary, or maybe your niece, nephew, or little brother, sister, whatever it is, you'll have a piece of paper and you'll fold it in half to make this butterfly. You'll draw one half. And I should have just drew one half. So you draw one half, like you have a piece of paper here, and you cut it in half, and you drew one half here, and then maybe it was like in paint, and you would close this paper, and on the other side, lo and behold, you would have this beautiful other side like that. So that's symmetry. So we were looking for a line that cuts it straight in half. So you don't want to do a line like this, because that doesn't cut in half. This side does not look at all like that side. So we want to keep it evenly cut in half. Line can be the line of symmetry because obviously it's not working. So let's get rid of that one. So we want to put that line of symmetry, and I know you knew it. I know you know it. You probably just pointed out like, this is simple, this is easy, and I'm trying to make sure it's straight. Right there's my line of symmetry. Bam. So good for you. That's the line of symmetry. Please know how to identify that. Now, the equation for that line. What is the equation for that line? Now this is where students get confused, and I'm going to help you out. Let me give you a hint. Let's identify some points on that line that's going to help us determine what equation we should put for that line. So this point right here is 210. So we got 210. This point here is 220. Let's move up here, give me some room. This point here is going to be 240. If I just jump up here, this point right here is going to be 270. And last point, just to make this point, you get it, make this point Okay, so what we're going to do is look at what's similar about every single one of these points. Come on, you can see it. Yep, we got a 2 in every one of them. But what about that 2? So where the 2 is not just in any place, it's always in what position? It's always in the X position. So no matter what point we choose on that line, X is always equal to 2. And there's our equation. That's how you can find it. Because it crosses through the x-axis, we're going to have x equals 2. You can remember it that way. Or if you forget, just go ahead and identify a couple of points on the line and realize, you know, it's never going to change. The same thing's going to happen if we were to find a y. All the y values would be the same in this case, but that's not the case here. So please remember that as we continue to work problems. All right, new graph. Can you pause it and work out the domain range? X-intercept, y-intercept, zeros, vertex, and axis of symmetry. All right, I'm hoping you paused it and worked it. So let me work it with you and show you what I'm getting. Let me show them, go back. Excuse me. All right, so let's do this one. All right, so our domain, remember our domain is which value? X or Y? Well, we want our X values, right? All the X values. So all the possible X values this could be. Now I want to draw your attention to the fact that there's an arrow down here, which assumes what? Which implies that this line is going to keep going on forever in that direction. So that's a big part of finding domain and range. Now, these X values, we're looking just at the X-axis. I could have a 2. It could be -3. I could have a -4. Can I have a -5? -5. Many would say no because they don't see that line touching -5, but there's an arrow there, which tells us this line is going to continue going in that direction for how long? Forever. So it's going to go that direction forever. And guess what? Our X values can be over here, 4, 5, it can be a 6, we can have a 7, we can have an 8, we can have a 9, 10, 11, 12. Can we have a 13? Well, some would say no because they see it stopping here. No, the graph or the coordinate grid stops there, but this equation goes on forever. That's why there's an arrow there. So you can actually have anything. So you could represent this by saying it can be infinity, but you won't see infinity on the test. What you're going to see is X can be all real numbers. So you'll see something like this R sign. All X values such that X is all real numbers. This is how you can read it. But this is X, it looks like XER, XER. It's saying that X is all real numbers. All real numbers. What are real numbers? Whole numbers, 1, 2, 3, 4, 5. Decimal numbers, 1.2, 3.4, -3, -4, -4.5. All real numbers are going to go on forever in both directions. What about the range? Well, let's think about the highest and the lowest for the range. So what's the highest value I can get in my range? The highest you can go. And sometimes you can take your ruler or a piece of paper and just kind of think through it like this. So if you had a ruler or something you wanted to use to try to think through this, you can put that in your paper and just think, what's the highest and lowest I can go? So let me go until I see the line on both sides, and I'm going up, and if it stops there. I can't go up anymore. So where did it stop? Notice that I'm going up and down because I'm talking about Y values now. So when I look across here, I see that I have a Y value of 7. That's the highest it's going to go. Now let's go down, and what can we get? So if I took it down, go down, it's going down, and where is it going to stop? Right there at negative what, 6? No, don't say that. Oh, -7? No, don't say that either. Why? Because we have arrows, so this thing keeps going how long? Forever. So it can have values all the way up to 7, but everything below it can be true for a range. So how do we represent that? You could say it can be between, some would want to write it -infinity all the way to 7 and write it this way. Y is greater than -infinity. Actually, you would write greater than, not equal to infinity, but less than or equal to 7. So some will write it this way, but you're not going to see it on your test. But you can think of it that way. But the way you're going to see it is more simple. And I like this way. You're going to see it, Y could be everything that's less than what? Less than 7. but not just less than 7. It could also be equal to 7. So this is how I'm going to set up that inequality. Y can be less than or equal to 7. What is my x-intercept? Well, that's where it crosses the x-axis. So if I follow this thing to the x-axis right there, nope, that's the y-axis. So let's keep on going. Follow it, follow it. There's my x-intercept right here. My x-intercept right there. And this is going to be at a -2, 0. And just know that the 0 is going to always be the case for x-intercept. What about y-intercept? Y-intercept is going to be where we found it a second ago. Right there is where it crosses this graph, this equation, this parabola is crossing the y-axis at that point. What point is that? That is at point 0, 4. My 0 is going to be the same thing as my x-intercept. My vertex is where? Oh, I wish you could talk to me so I could hear you. 4, 7. That's the highest point here. 4, 7. So it's the highest point. That's my vertex. It's the highest or lowest point. Is that a maximum or minimum? I'm hoping you're saying maximum. And here's the one I want you to make sure you get. Axis of symmetry. So I'm going to erase all this other stuff to make sure we get that right. Axis of symmetry. So where is that going to be? Well, it's going to be right down this middle. And what's the equation for that axis of symmetry? Well, no matter what point you pick on there, all the x values are going to be 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and so on. So you know that my equation is going to be x equals 4 is my equation. So I'm going to write my equation as, hopefully you did the same thing, x equals 4. All right, now this is a different situation here, because now we have this little open thing going on, and we briefly talked about it before, but what does that mean? So this is an open circle, and it's suggesting that it's not equal at this point. So you can't say it's equal here. So let's talk about domain and range. I want you to pause it and answer this question before I do this one. So figure this one out, please. All right, so our domain is, what is our domain? So let's look at all the x values. Can I x equal 0? No, there's no graph here going through 0, going through the y-axis. Can I x equals 0.5? Nope, nothing here on 0.5. Can it equal 1? Let me get my, see if I can get my ruler out the way. All right, so let's go back to there. Can it equal 1? Yep, it could equal 1. Or can it? Actually, it can equal 1 because it's an open circle there. So, but can it equal 2? Yep. See, I'm looking at my x's to get my domain. Can we equal 4? Yep. What about 5? Yep. 6. Almost 6, right? No, it can't equal 6 because what? This arrow says it's going to keep going in that direction. Matter of fact, can it equal 10? It's going to be hard to think of it equaling 10 because you're like, it's not even over there. But you got to imagine this line is going to keep going that direction and eventually hit 10. Matter of fact, it's going to hit 100. It's going to hit 1,000. Given enough time, it's going to hit every single number going that direction. So we're going to say that our x can be greater than 1, but it can be equal to 1. It could be anything that's greater than 1. All these numbers from 2, 3, 4, 5, 6, 7, 8, and 10. So I'm just looking at the x-axis. What about the range? Well, the highest on my range, I'll take the ruler back out. The highest on the range goes furthest up here is 9. So, but how far can we go down? It's going to go down forever because of that arrow. So don't stop there at 5 and think, oh, no. This line is possible that it can go this way all the way down. So we're going to write this as everything that's less than 9. Can it be equal to 9 at that point? Absolutely. There is no open circle at 9. So we're going to say it can be equal. X-intercept. Well, where does this line cross the x-axis? Let's see. It crosses right. Aha. We don't know. Does it cross? Yes, it crosses. But unless we have an equation, we're not going to know exactly where it crosses. And unless it crosses it through a exact point. So it does have an x-intercept because it's arrow, but we don't know where. What about a y-intercept? It does not have a y-intercept because it has an open circle here and it does not have an arrow. So same answer for our zeros. Vertex highest is going to go is 3. So that point is going to be at 3, 9, and a maximum of, and I'm sorry, that's called the maximum. What's the equation? The line of symmetry is right here. And I want to make this point now because you look on both sides and you say, Mr. Clayton, that's not even. You say it has to be even. Yep. This one's not even, so now I have to make a correction because this is not even. You want to go through your vertex. You're going to always find your line of symmetry through your vertex. So if I have a vertex at 3, 9, I know there's going to be a line of symmetry at x equals 3. So x equals 3. So right, and you see it goes through right here. So it doesn't have to, you don't have to make sure the line is equal on both sides, but you do want to go through that vertex because they'll often do that where they have half a line kind of stop here and they want to see where you're going to put that vertex. All right, try this one. Pause it here and work that one. All right, so let's go ahead and do this one kind of quickly. This one's going to go on forever in the x direction there. So you see 6, 7, 8, 9, 10. It's going to go on forever to the negative numbers. The highest is going to go is 0, 1, 2 is 2. Can it go to 3? There's nothing for 3, nothing for 4. So I have all my x values that are less than 2, or this is filled in, so I can say equal to. For my range, I can say it's the lowest we're going to go. Now I'm going to have to approximate here, right? So they're not going to expect you to know the exact number, but they do want you to understand that this is negative for 1, and this is a negative 3. So it's between negative 2 and negative 3. So I'm going to guess that it's negative 2.5. And what about my range on the other end of the spectrum? So the lowest is going to go is about negative 2, let's say negative 2.5. Is what we're saying this point is. We're estimating. The highest is going to go is where? Here? 5? Don't say that one. Why? Because it's possible. We want all the possible y values. So it's possible it can go all the way up here, and that's the one we're going to take. So we say our range is y can be greater than or equal to negative 2.5. What about our y-intercept? So our y-intercept is where it crosses the y-axis. Where is that at? Right there. So it looks like about 0, negative 1. So we're guessing about 0, negative 1. X-intercept is at negative 4.5. Now, if you're worried about what if I get a question like this on the test that's a little bit arbitrary and it's hard to see, you're not. They're not going to get something that close. This is just for communication purposes when we're testing this and when we're talking about it, so you can understand about what's going on with x-intercept, y-intercept, and so on. There'll be multiple choices and it'll be easy to see which one is clearly your x and y intercepts. Vertex is going to be right there. That's the lowest point this time at a negative 2, negative 2.5. And again, with the vertex comes my axis of symmetry because I know it's going to go through that vertex every time. And so it's going to look like that. Bam, that's a beautiful line. Almost perfect. All right, so we're going to say x is equal to negative 2 because we see that negative 2 here, and it's going to be negative 2, and we see it there. Time for some star questions. What does it look like on star? Can you answer the following questions correctly? Let's see. Which graph best represents a function with a range of all real numbers greater than or equal to negative 6? A, B, C, or D. Which one would you choose? So this is just a vocabulary question. You don't have to pull out a calculator or anything. You just need to know this key word. What is range? So if you know ranges are your y values, you just simply start looking for one that starts at negative 6 and numbers greater than that. So this is starting at 0. See, they put it at x equals negative 6. That can't be it. We're looking at a y value that's from negative 6 and up. This starts at negative 6 and it goes everything above it. All the numbers are above that. So this one looking pretty good. This starts at an x is negative 6. Again, I told you, if you know the vocabulary that this is y, you're not starting at an x value of negative 6. And this one's at a negative 6, but they got all the values that's less than negative 6, but they want it greater. So our answer becomes clearly C. All right, so let's look at this problem where it says the graph represents a function with a domain of all real numbers greater than or equal to negative 7 and less than 2. Greater than negative 7, here's negative 7, greater than or equal to -7 and less than 2. So which one's greater than -7? So I'm looking for -7 first for my x value. So I'm just looking for this line. And this is greater than -2, but we want it greater than -7. So this is not going to work. I want it greater than -7. This is everything greater, but it's greater than -3. No, I don't want that one. This line is greater than -4 because it's everything going to the right. That's greater than -4. That's not going to work. So this one is equal to -7, which is fine, and is everything greater than -7, which is good. And it's less than 2, so it's less than 2. Notice there's an open circle here, so it's less than but not equal to 2. So obviously D is going to be our choice for that one. All right, so here's our star practice. What is the domain of f of x equals 9 minus x squared? Whoa, I don't know. Where's the we don't have a graph. How do we figure this one out? Well, I'll tell you what, we have a calculator, so we can pull up a graph, and that's what we're going to do. So let's take out our graph, and let's just put that in our graph. Now, they put this in a funny order, right? It's usually x squared first, but it doesn't matter. If they want us to write like that, we can. I would normally switch it around, but we can keep it that way. So we'll do 9 minus x squared. So that's what I would do. I would honestly just graph it so you can visualize it and get an idea. By this point, hopefully you're able to know what it looks like in your head just from looking at it, but if not, just pull it up. So I'm pulling it up on my calculator, and this is what I get. They want domain. Domain is my x values, so I can see that this is going to go on forever. Like, this is going to go on forever in this direction. Matter of fact, if you were skeptical about that, and I pulled up a table, I can show you. Look at the x values right here, 1, 2, 3, 4. It's going to go on forever. You thought it was going to stop where we could see. Oh no, it's going to go on to 100 to 200 and so on. So I just want to make that point very clear. It's going on forever in the negative situation and the so I can go up all the way to the negatives and do the same thing. As you see, -289 is going on forever this way. So let me draw an arrow just so you can see it. Just because it looks like it's going straight up and down, trust me, it's going to keep going that way. It's going to keep going this way. So it's all these numbers for my domain. Guess which one most people like to pick? We want to think about the y value and start thinking about where it's limited. Like, oh, it stops up here about 9, 2, 3, 4, 5, 6. It's probably 9. And so sure enough, they have a 9 up there. Or they have -3 and 3 because someone's going to think about the x-intercepts or the solutions and zeros as they're called. Nope, we want the domain, all the possible values of that function. So you want to pick all real numbers here. So it seems too good to be true, seems too easy, right? But that's it. All right, let me get another graph. All right, so what is the range of this one? Again, I would just graph it. Before I even read the answers, matter of fact, again, you may be able to graph this without any problem. X squared is a parent graph that just looks like a parabola. +1 is going to be moved up just 1. So I just know that just from the practice. And if you don't know that now, hopefully you'll learn it as you continue on in a few weeks. But if you don't, just put in the calculator. So I'm going to put this in the calculator, and this is going to be x plus 1. I'm sorry, x squared plus 1. And there it is. So just like we drew it. So what is the range now? So underline range and make sure you put y. I want the y values. So I'm just looking at how this line here, all the possible ways it can go up and down. I don't care if it goes this way to the left and right forever. I want to know what's the minimum and maximum for the vertical part of this graph. So the lowest I can go is a what is that? 0, 1, and the highest I can go is what? Well, it's going to go on forever. So we can pull up the graph and show that again, but this graph is not going to stop. It's going to go on forever. So I know it's everything. And notice I'm not looking at my choices yet. I'm just thinking through it, because sometimes the answers are set up in such a way as to throw you off, and you start thinking, yeah, that's a good point. But go with what you know. You studied this. You got this. So we're going to say y can be greater than 1. It can also be equal to 1. So it can be any of those greater than or equal to 1. Let me go back to the graph to make sure you see that. So you see it's from 1 and everything up. Can it be 0? No. Can it be -1? No. So let me see an answer that matches what I said instead of trying to check the answers first. All real numbers? Nope. Can be everything. It's not negatives. It's not 0. All real numbers greater than or equal to 0? No, it's not equal to 0. So that can't be 1. All real numbers greater than or equal to 1? Absolutely. All real numbers less than or equal to 1? No, no. It's absolutely the opposite. So we're going to pick C as our choice for that one. All right, let's look at this number 20. 2013 question 20. They had a question like this. The function below can be used to model the area of a rectangle in square inches. A, if the rectangle has a perimeter of 72 inches and a width of W inches. Given this equation, what is the domain of this function? So it's simple as we can just put that function in the calculator and look at what it looks like. So let's put that in, 36. And we're not going to put X, W, of course, because it can't understand what W is. So we're going to put X, and that's going to be X squared. And we press enter. And what is that? It can't see anything, so we're going to, my first go-to is always fit. And I can kind of see where it's going now, so I'm going to zoom out. I'm going to zoom out about right over here. And now I'm going to press escape and drag it where I want it to. And I'm starting to kind of, okay, I'm seeing where it's crossing at 0 and some other number here. Now, I want to be sure that's 0, so to find out for sure, I'm going to analyze it at a 0. And yep, that is a 0, 0. And I'm going to move this over and get this point too. Analyzing it for 0, and I find that it's, there it is, 36. You can't hide from me. I saw you over there. So it can be all values of X, in this term, in this case W, from 0 to 36. So anything from up here, we can't take these numbers below there because we're dealing with an actual problem here. We can't say it's all these real numbers. So if anything between 0 and 36 is what we want to do. So you see the answer just as I see it. J is what we're going to be looking for there. All right, did we complete our objective? You bet we did. We determined the domain and range of quadratic functions and represent those functions as inequalities. We did that all throughout this lesson today. And we talked about intercepts, y-intercepts, zeros, maximums, minimums, vertexes, and axes of symmetry. Guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.